Okay, first question says reflect triangle A in the line x equals 1. I'm not using a ruler here, but you would draw, first of all, with your ruler, your line x equals 1. So there's your line x equals 1. And then you want to reflect. So if you count here, this point is 2 squares away from your reflection line. So you go 2 squares across again, and you mark that on. So that takes me to this point. This next point here, it is 3 wee squares away, so 3 wee squares away on the other side. And then this point is 5 squares away, so 5 squares away on the other side. And using your ruler again, of course, the link goes up, and that's your first question done. Question 2, it says, what is the main difference between binary number system and decimal number system? So I know the main difference. What would you say? The main difference is binary involves ones and zeros. Involves only ones and 0, and yep, that would be the main difference. And then I don't think they would, for 1 mark, I don't think they want you to go into much more detail than that, and maybe when you see the actual mark scheme that might be wrong, who knows. Okay, write the binary number and a whole pile of ones as a decimal number. So to do this, first of all, I would write down 2 to the power 0, 2 to the power 1, 2 to the power of 2, 2 to the power of 3, 2 to the power 4, 2 to the power 5. How many have we got? We've got 1, 1, 1, 1, 2, 3, 1, 2, 3, 4, 5, 6. So there we are. Okay, so 2 to the power 0, start from here, that is 1. 2 to the power of 1 is 2. 2 to the power of 2 is going to be 4. 2 to the power of 3 is going to be 8. 2 to the power of 4 is going to be 16. 2 to the power of 5 then is going to be 32. So you just want to add those all up and see what you get. So it's non-calculator, so I would do this as smartly as I can. So 32 plus 8, first of all, pair those off, that is going to be 40. 16 plus the 4 is going to be 20, and then you've got the 2 and the 1, which is going to be 3, so that's going to be 40 plus 20, 60 plus the 3 is going to be 63. Next one says write the decimal number 87 as a binary number. First of all, the biggest power of 2 which goes in, biggest number which is a power of 2 which goes into 87 is 64. I'm going to leave a gap where my 32 would have been. It's not going to fit in. Would 16 fit in? It would, because 16 plus 64 would take me up to 80, so I'm now up to 80. 8 is the next one. It wouldn't fit in. 4 would fit in. Would take me up to 84. 2 would fit in, and 1 would fit in. So that is 1, 0, 1, 0, 1, 1, 1. And that is it. So put that into your answer line. Okay, next one, simplify this. That is just adding your powers, w to the power of 5 then. Next one, subtracting your powers, y to the power of 4. Work out the nth term. It's going up in 7s. So if you go back, you're going to get 0. So it's just 7n plus 0, which is just going to be 7n. Work out the value of, so that is 1 over 5 squared, which is 1 over 25. And then the next one, 1 to the power of 5 is just 1. Anything to the power of 0 is 1, so it's just going to be 2. So I'll write those in, 1 over 25 and then 2. Firing through this now. Okay, right, draw the following table gives us some values of the quadratic equation. On the grid below, draw the graph of this thing for the values between -2 and 4. So we're just putting that in, nothing else. That's all we're doing. Okay, so we're just putting those in. So when your x value is -2, your y value is 11. When your x value is -1, your y value is 5. 0, you're at 1. 1, you're at -1. 2, you're also at -1. 3, you're back to 1. 4, you're going to be back to 5. And then we have to do this. All right, I'm going to pause the video and then do this because it's tricky enough to do here. Okay, I've made an effort at that. It's not fantastic, to be honest. Maybe we should continue it on a wee bit, but there you can see what we've got. Right, my results aren't going to be very accurate for the next bit. I'm going to imagine it's going to say, yep, use your graph to estimate the value of x for which y is equal to 3. Right, I will use a ruler for this one. So I can get a ruler. So at y equals 3, draw your line y equals 3. So there's y equals 3 drawn. and you're zooming in and you're seeing what this x value is. So it's not too bad. Trace down with that. 3.6. So x equals 3.6, and the first one then was going to be, and that looks like minus, that's 2b squares in, is it? Sorry, it's not. Oh, it's 3 squares in. Minus 0.6. Minus 0.6. Okay, the minus is not going to be very accurate again, like the one earlier on, because of my bad diagram, and also doing it on this doesn't make it easy. But you get the idea. Okay, next one. Toby walks his dog in a field, A, B, C, D, so he is always more than 40 metres away from A, and nearer to A than B, and nearer to DA than DC. So shade the area where he walks. Okay. Okay, I've paused the video there and I've just marked in a few things. So more than 40 metres from A means a circle, centre, A, radius 40 metres. And 40 metres, it says here at the bottom that the scale is 1 centimetre is 10 metres. So 40 metres would be equivalent to 4 centimetres. So I'm going to open and compass out and do a circle, radius 4 centimetres from A. So the circle is going to go around here somewhere. Next one, it says it is nearer to A than to B. So nearer to A than to B is a perpendicular bisector of AB. If you measure AB, it's 14 centimetres. So divide that by 2, it's 7, and you can just draw your line down the middle. And then nearer DA than DC, so that's nearer this line than this line. That's the angle bisector of D, so we'll need to do that. Okay, I'm going to draw my circle first of all. Radius 4, and this is going to be awkward to do in this. I'm actually not using a protractor, or sorry, a compass. I'm using a protractor to do this, but there we have it. So it's going to be further away than that. So that's roughly what that looks like. And then to do my angle bisector, you open your protractor, put your point of your protractor at D, open your protractor, or your compass, sorry, a certain amount, and do a wee arc, and then another one on around here. Oops, the same size. There we are. That'll do. Okay, and then keeping your protractor open the same amount, go to that point. I'll call that point X, and I'll call it point Y. So put the point of your protractor at X and do an arc inside. Then move your point of your protractor to Y and do an arc inside, and then link your D, I'll call this point Z, link D and Z with a straight line using your ruler. Okay, and I'll just zoom out and then I can continue that. So that's what we've got. It's an absolute mess, but there we go. Okay, right, so we're good. So we've got our angle bisector done. We've got our thing. So let's read the question again. Toby walks his dog in a field, so he's always more than 40 metres from A. So he's not in this circle here, not in here. And he's nearer to A than to B, so he's closer to here, and he's also nearer to DA than to DC. So this is a wee bit he's going to be in. So I'm going to shade that. I'll shade it in green so we can see it. So this is where he's going to be. Oh, and I've made a mistake. Nearer to A than to B. I should have shaded that last wee bit. Get rid of that last wee bit. And that is us sorted now. Okay, so it's just in there. That's where he is. I'll shade that in properly so we can actually see it then. So that's where he should be. Okay, that's an absolute mess, but there we know. Okay, next one. It says a tent in the shape of a cone has a perpendicular height of 7 and a volume of 220 metres cubed. And it has a perpendicular height of 7. And we know that pi as well is 22/7. So work out the base of this this tent. So it's a cone. The volume of a cone is 1/3 times pi r squared h. Well, it's going to be tricky enough then. So we're going to say 220 is equal to 1/3. Just fill in what we know, times pi, which is 22/7. times my r squared, and then times my h, which we know is 7. I'm going to write that as 7 over 1 to make life a wee bit easier. Okay, so what can we do? We can cancel. That 7 can go with that 7. And what else can we do? Not an awful lot. That's not great. We will just have to work on with that. But that has still made things a wee bit easier. We've now cancelled down to 220 is equal to, I'll write that as 22 over 3 times r squared. And then what we could do is just bring that across. That means 22 over 3, 220, sorry, times 3, and then over 22 then will be equal to r squared, and then very nice. Something else cancels here. 22 goes into itself once, 22 goes into this 10 times. So we have just got, then 10 times 3, which is 30, is equal to r squared. And then your r is equal to the square root of 30. And does it tell me to leave it as a surd? It does give your answer in a surd form. And root 30 can't cancel down, so that's as good as we can go. And that's going to be meters. Okay, next one. We've got, it's a standard form question. It says work out the value of this thing. So we've got m divided by n. So 4.5 times 10 to the power of 7 divided by 5 times 10 to the power of minus 3. Okay, divide the normal numbers. 4.5 divided by 5 would be 0.9. And 10 to the power of 7 divided by 10 to the power of minus 3 is 10 to the power of 7 minus 3, which is 7 plus 3, which is 10 to the power of 10. And just check that. It's not in standard form at the moment. So make this bit 10 times bigger, so it becomes 9, which means this bit has to be 10 times smaller, so it becomes 10 to the power of 9. And that should give you your correct answer. Next one says make Q the subject of the formula. Okay, in this one you've got your thing is on the bottom line. You want to find Q, make Q the subject. It's on the bottom line. Generally in mathematics, if the thing is on the bottom line, it's a problem. So multiply across by that bottom line, the denominator, to get it off the bottom line. And I think then the nicest thing to do is just multiply out. So you'll have PR minus PQ is equal to Q. I'll bring all my Q's to one side. So I'll have Q plus PQ, and then I'll factorize. So I'll pull a Q outside a bracket, leaving me 1 plus P, and then this thing is multiplying the Q. So when it goes across, it is just going to divide. So you'll have PR over 1 plus P is equal to Q, and then your last line, write that in. Q is equal to PR over 1 plus P. So there you have it. Okay, next one, getting through this as quickly as I can. X is a number between 0 and 1. Oh, right, okay. So X is a number with a value between 0 and 1, so it's a decimal number. From the following list, which would be the lowest value? Oh dear, that's a tricky enough one. The lowest value then, so if it's a fraction, let's have a look at them. So say that's a fraction, so minus x to the minus 3, we'll do this properly, we've forgot. So we'll let x be equal to a half, and then x to the minus 3 then is going to be equal to a half to the power of minus 3, which is going to be the same as 2 to the power of 3, which is going to be 8. 1 over x would be equal to 2 over 1, which is just 2. Then x is just equal to a half, and then x to the power of a half, why did I pick a half? That is going to be the square root of a half. So which of these things is the smallest? We've got 8, clearly not the smallest. 2 is clearly not the smallest. A half is smaller again, but the square root of a half is going to be the smallest. So my answer is going to be x to the power of 1/2. Okay, which would have the biggest value? So again, because we set it this way, we can see it would be the x to the minus 3. It gave us 8. It would have the biggest value. Okay, next one says 3 over 4 root 5 can be expressed in the form a root 5. Find the value of a. So we have 3 over 4 times root 5. Rationalize the denominator by multiplying top and bottom by root 5. You will get 3 root 5 over 4 times root 5 is 5. So that really is 3 root 5 over 20. And you could write that as 3 over 20 times root 5. That means your value of A is equal to 3 over 20. Number 11, a scale model of the car is made. The length of the model is 1/10 of the length of the car. The volume, okay, so to get from, the model to the real, you would multiply by 10. That's if we're looking at length. For area, you would multiply by 10 squared. For volume then, what we're talking about, you would multiply by 10 cubed. So the volume of the petrol tank of the car is, so what is the volume of the petrol tank of the model? So if you multiply to get from the model to the real, you multiply by 10 cubed. If you're going back the way, you're then going to divide by 10 cubed. So our answer is going to be 50,000 divided by 10 cubed, which is just going to be 50,000 divided by 10 cubed is 10 times 10 times 10. So 50,000 divided by 1,000 is just going to give me 50, and that's going to be centimeters cubed. Okay, oh lovely. Right, our recurring decimal question. Express the recurring decimal as a fraction in its simplest form. I like to say let R equal, and what was it, 0.2696969. I'll just do a couple of those out to show it repeating. Two different digits repeating, so you are multiplying by 100, and then you will get 26.696, sorry, that is wrong, 26.9696. Okay, and then write the original thing below it again, making sure you line up the decimal points. And then if you subtract, you'll get 99R on the left-hand side. And if you subtract on the right-hand side, you imagine that those 9s will go, those 6s go, those 9s will go, those 6s will go. And you'll be left with 26.9 minus 0.2, which is going to give you 26.7, which means R is equal to 26.7 divided by 99, which is right, but very ugly. So you'd multiply top and bottom by 10 to give you 267 over 99. Oh, forgot to multiply by 10, 990. And then does that cancel down any? I don't think so. Okay, try dividing by, well, it doesn't divide by 2. Try dividing by 3. 23 goes in at 26, it goes in 8, and, oh, it does. So it's going to be 889 on it, and then 330, and that's as good as we can go. Okay, next question says, a circle of radius r centimeters has a circumference c. Just write down what c is. C is equal to 2 pi r, and an area of a centimeter squared, so that's pi r squared. And circle whether each value is rational or irrational. So basically it's going to be irrational if it involves pi, I'd imagine, is what they're going to be looking for here. Let's have a look and see. So the first one, so we'll call this number 1, number 2, and number 3. So for number 1, if your r is equal to 3 over pi, c is equal to 2 pi r is equal to 2 times pi times 3 over pi. And what happens is those pi's cancel out, just giving you 6. That's going to be rational. Definitely I wouldn't try and jump in and guess these. They're not maybe as obvious as you might think. Your area is going to be pi r squared. So it's going to be, in this case, it's going to be pi times 3 over pi squared. And that would become pi times 9 over pi squared, which would become 9 over pi, which is irrational. For number 2, it was root of 3 over pi. And my circumference is going to be 2 times pi times root of 3 over pi. That is going to be an absolute mess, but it's going to be irrational. My area is pi r squared. Let's have a look and see. So in this case, that's going to be pi times, square that r, you're going to get just 3 over pi. And then your pi's will cancel, just give me 3. So that one is rational. So just a normal number. For the next one, it was 3 root pi. So my c is equal to 2 times pi times 3 root pi. So that's going to have a root pi's in it, so it's going to be irrational. So that one's irrational. and the area is going to equal to pi r squared. Sorry, that was my r. I forgot to write that in. That was my r. That's going to be pi times 3 root pi squared. So if you do that out, that's going to be pi times 3 squared is 9 times pi. Which is just going to be 9 pi squared, which is going to be irrational again. So definitely I would have to do those out. Good bit of working out for those questions. And that is it. So there's 4 marks for that question. I don't know where they're giving how they're doing the 4 marks, since there's 6 things here. Not sure. Okay, this question says, cuboid has sides of length 3 plus 2 root 3, 3 plus root 3, and 9 minus root 3. Find the length of the space diagonal, giving your answer in the form a root b. Okay, right. Space diagonal, first of all. If you imagine I've got a cuboid, like so. And, oops, there we go. The space diagonal is from the front bottom left to the back top right. And how you would get it, it would be, if you can imagine I've got a side here A, that's a side B, and that's a height C. The length of this thing that I'm going to highlight here in green, length of this line in green is going to be equal to A squared plus B squared plus C squared, and then it's a square root of that. So I think I'll break it up and look at my A squared, which is going to be 3 plus 2 root 3 upon 3 plus 2 root 3. And I'm just going to work this out and I'll piece them all together then at the end. So if you do that out, 3 times 3 is going to be 9. 3 times 2 root 3, so I've done 3 times 3, then I've got 3 times my 2 root 3 would be 6 root 3. I have another one of those, so that's 6 root 3 plus another 6, which is going to be 12 root 3. And then I've got 2 root 3 times 2 root 3. 2 times 2 is 4. Root 3 times root 3 is 3. 4 times 3 will be 12. And then we'll tidy it up. 9 plus the 12 is going to be 21 plus 12 root 3. My second thing then, b squared is going to be equal to 3 plus root 3 upon 3 plus root 3. And if you do it out, you will get 9 plus 6 root 3, and root 3 times root 3 is just 3. So if we tidy that one up, we are going to get, that's just going to be 12 plus 6 root 3. Same idea, your c squared is going to be equal to, and c was 9 minus root 3, so it's 9 minus root 3 upon 9 minus root 3. And if you do that out, you're going to get 81 minus 18 root 3, and then plus 3, which is just going to be 84 minus 18 root 3. Okay, so we need to find L, which was equal to the square root of a squared plus b squared plus c squared. So if we add up all those bits, and let's have a look, where our a squared plus b squared plus c squared, you're going to have the numerical bits, you're going to have 21 plus 12, which is going to be 33, plus 108, which is going to be 117. So L is going to be equal to the square root of 117. We'll also have a square root bit. Let's have a look at it. The square root bit, I'll do it in red. You've got 12 plus 6 root 3, 12 root 3 plus 6 root 3 minus 18 root 3. So 12 root 3 plus 6 root 3, 12 root 3 plus 6 root 3 is 18 root 3, and then minus 18 root 3 gives you 0. So it is just equal to the square root of 117. And the square root of 117, let's have a look at it. You could write that as 9 times 13, which is the same as root of 9 is 3 root 13, and that's what they're looking for. Okay, last question on the exam. It says a bag contains X green and 5 red beads. 2 beads are taken without replacement from the bag. What is the probability of taking 2 greens? Okay, probability of getting your first green, and it says if X is equal to 3. So getting your first green, you've got 3 greens out of a total of 3 plus 5 out of 8. Your second green then, there's only 2 greens left and you're down to 7. You can just do that by cancelling down would be easiest. So 2 goes in itself once, 2 goes in the 8 4 times, and then multiplying on the top you'll have 3, multiplying on the bottom you'll have 28. Okay, so 3 out of 28. It says what is probability of taking 2 green beads if X has a larger value of 10? So X is now 10. So you've now got 10 greens out of a total of 10 plus 5 is going to be 15. If you've already taken one out, you're down to 9 greens out of 14. And again, use a bit of cancelling down here. So first of all, 5 goes into 15 3 times, 5 goes into 10 twice, and then 2 goes in itself once, 2 goes into the 14 7 times, multiply, what else can we do? 3 goes in itself once, 3 goes into the 9 3 times, multiply along the top, you'll have 3 over 7. Okay, and the last bit says, hence find the smallest value of x for which the probability of taking two green beads is greater than a half. Okay, there is an algebraic way of doing this, but it goes into GCSE further maths, so they just expect you to just keep going and trying another thing. So we already know that if you have 10 beads, the probability of getting 2 greens, if you have 10 greens, the probability of getting 2 greens is 3 over 7, so that's not greater than a half. So we're going to try x is equal to 11. So it really is just trial and error here, really just keep going and seeing. So it's going to be 11 out of a total of 11 out of a total of 16, and then the next one would be 10 out of 15, and we're just going to cancel down again. 5 goes in that twice, 5 goes in that 3 times, and 2 goes in that once, 2 goes in that 8 times, so it's just going to work out as 11 over 24. It's not greater than a half. Why as well? First of all, that's not greater than half. If you do 11, multiply 11 by 2, you get 22. So it's not bigger than the denominator when you double the top line, so it's definitely less than a half. Okay, so we're going to try x is equal to 12. So it's going to be 12 over 17 times 11 over 16. And then again, let's do a bit of cancelling down. 4 goes into that 3 times, 4 goes into that 4 times. That's going to be 33 over, and that's going to be 4 times the 10 is going to be 44 times that's going to be 68. So it's not quite good enough. Almost double the top line here. You'll get 66. So it's very close to it. So you can see seems like we're getting closer to it. X is equal to 13. This could be our one. And it's going to be 13 over, and it's going to be 18 times 12 over 17. And then let's do a wee bit of cancelling down again. 6 goes into that twice, 6 goes into that 3 times. Multiply along the top, you're going to get 26. Multiply along the bottom, you're going to get 3 times 10 is going to be 30. 3 times 7 is going to be 21, so that's going to be 51. And have a look here. If you double this, you will get 2 times 26 is going to give you 2 times 26 is going to give you 52. That means that must be greater than a half. So that means your answer, hence find the smallest value of x for which the probability of taking 2 green beads is greater than a half. So your answer, the smallest number of beads, is 13. And that was the last question on the paper.